Hello. In this video, I will continue with section 6.1. The next topics are the greatest common divisor and the least common multiple. So this is what the greatest common divisor is. Let's copy the definition. The greatest common divisor, or GCD, of two natural numbers is the largest natural number that divides both numbers. This is on page 243. But I'm going to show you the example in the book. Okay, so let's share the screen. For small numbers, you can find the greatest common divisor by looking at the numbers and identifying the largest natural number that divides both numbers. For example, to find the greatest common divisor of 24 and 40, we list the divisor of both numbers. And we can see the divisors of both. The divisors of 24, or some divisors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And the divisors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. And you can see that the largest number that divides both is 8. But for large numbers, it's not going to be the most practical method. For larger numbers, it is tedious to list all divisors of both numbers. So we use the approach in example 5. Okay, that is, we're going to use prime factorization to find the greatest common divisor. So I'm going to do an example that is slightly different. We are going to use prime factorization to find the greatest common divisor of 720 and 640. So listing all the divisors, that's going to take a lot of work. I mean, we have so many divisors that it's not going to be very practical to list all the divisors one by one. What we're going to do is use prime factorization. We're going to write each number as a product of primes. So let's do 640. We're going to use factoring trees. If it ends at 0, 640 can be factored at 64 times 10. So if it ends at 0, it's divisible by 10. And then 10 as a product of primes is going to be 2 times 5. Once we only have primes in the branches, at the end of the branches, we stop there. 64 is 8 times 8. And 8 factors as 2 times 2 times 2. Okay, so 640 as a product of primes is going to be a product of 7 twos and a 5. Or you can write this a little bit shorter as 2 to the 7th times 5. And 720, we're going to write this as a product of primes. So 720 is divisible by 10. 10 is 2 times 5. 72 is 8 times 9. Where 8 is 2 times 2 times 2. And 9 is 3 times 3. So 720. Okay, so I'm going to cut this. and we're going to write them together. So 720 as a product of primes is going to be a product of 4 twos, 2 threes, and 1 5, or 2 to the 4th times 3 squared times 5. So know that 4 twos and 1 5 divide both. The factors in common are those. Four twos and 1 5 divide both. And the greatest common divisor is going to be the product of the numbers in common, the product of them. So the greatest common factor so this divide both, then, or thus, the greatest common divisor of 640 and 720 is going to be the product of the common factor. So that's the product of 2 4s and 1 5. That is a product of 2 4s or 4 2s is 16. 16 times 5 is 80. So that's going to be the greatest common multiple of 640 and 720. Okay, so that's the greatest common divisor, and the least common multiple, from the name, as you may imagine, is the smallest number that is a multiple of both numbers. Okay, so that's on page 244. The least common multiple, or LCM, of two natural numbers is the smallest natural number that is a multiple of both numbers. So for small numbers, it's fairly easy to list the multiples and find the least common multiple. Let's say we want to find the least common multiple of 8 and 6. So we can list the multiples of both numbers and then choose the smallest common multiple as follows. So some multiples of 8 are 8, 16, 24, 32, 40. That is 8 times 1, 8 times 2, 8 times 3, 8 times 4, and so on. And multiples of 6. Some multiples of 6 are 6 times 1, 6 times 2, 6 times 3, and so on. So we can see that the smallest number that is a multiple of both 8 and 6 is 24. However, for larger numbers, we can use a prime factorization approach to find the least common multiple, similar to what we did in example 5. We didn't do example 5, but I'm going to use the same two numbers. We are going to find the least common multiple of 640 and 720. So we found that 640 as a product of primes is a product of 7 twos and 1 5. So that's 7. And 720 as a product of primes, it's a product of 4 twos, 2 threes, and 1 5. So we observe that 640 requires 7 twos. 720 requires 2 threes. And they both require 1 5. So the least common multiple of 640 and 720 is going to be the product of the primes that are required or that appear in the prime factor or in the prime factorization of both numbers. That is going to be a product of 7 twos. So 640 requires 7 2 and 720 requires 4 twos. So we're going with the 7. 720 requires 2 threes. And there's 1 5 involved in both. So that product is going to be 5,750 or 5,760. Okay, so keep in mind that do not use any more primes than you absolutely have to, because you're going to have a common multiple, but it may not be the least common multiple. So we don't want to use any more primes than we absolutely have to. Okay, on the next page, we have the guidelines to find both the greatest common divisor and the least common multiple. To find the greatest common divisor and least common multiple of two numbers, do this. Factor both numbers as a product of primes or product of powers of primes. To calculate the greatest common divisor, multiply the smallest powers of any primes that are common to both numbers. And to calculate the least common multiple, multiply the largest powers for all primes that occur in either number. Okay, so we're going to do another example. Well, actually, not yet. I'm going to give you the following relationship between the least common multiple and the greatest common divisor. If A and B are two numbers, then the following relationship holds. The greatest common divisor of A and B multiplied by the least common multiple of A and B equals the product of A and B. So in the example we did, the greatest common divisor of 640 and 720 is 80. And the least common multiple of 740 and 640 and 720 is 5,760. So 80 times 5,760 is equal to 640 times 720. and they are both equal to 460,800. Okay, so far we have seen two methods for finding the greatest common divisor and least common multiple. The first one is by, this one is the better approach for small numbers. Just list the divisor and the multiples and identify either the GCD or the LCM. Another method is using prime factorization. And there's another one, is the Euclidean algorithm. So I'm going to write this a little bit different to what the book does. So a third method for finding the greatest common divisor is the Euclidean algorithm. Okay, so there are two steps. Step number one, divide the smaller number into the larger number. And step number two, divide each number into the previous divisor. And repeat this process until you obtain a remainder of 0. Okay, so we're going to find the greatest common divisor of 56 and 72. And if we know the numbers in the greatest common divisor, we can also find the least common multiple. Okay, but first we're going to find the greatest common divisor of these two. So the Euclidean algorithm, I should say, do that by using the Euclidean algorithm. Okay, step number one is to divide the smaller number into the larger number. Okay, so yeah, let's do the division. So step number two, divide each number into the previous divisor, or each remainder, I should say, each remainder into the previous divisor, and repeat this processing until we obtain a remainder of 0. So next we're going to divide 56 by 16. Okay, so the remainder is still not 0. Step number 3, or not step number 3. Next, we continue the process until we obtain a remainder of 0. Okay, so once we obtain a remainder of 0, we stop. And the greatest common divisor is going to be the last divisor. So this one is the greatest common divisor. Okay, so thus the greatest common divisor of 56 and 72 is 8. And we can use the Euclidean algorithm to obtain the least common multiple. So also, we know that the greatest common divisor of 56 and 72 multiplied by the least common multiple of 56 and 72 equals 56 times 72. The greatest common divisor, we found this to be equal to 8. We want to know what is the least common multiple. And 56 times 72 is equal to 4,032. Okay, so the least common multiple of 56 times 72 must be equal to 4,032 divided by 8, or 504. Okay, we're going to do an example similar to this one. We're going to use the Euclidean algorithm and the relationship between the LCM, the GCD, to find both the least common multiple and the greatest common divisor. We're going to use the Euclidean algorithm to find the greatest common divisor and the least common multiple of 231 and 504. Okay, so let's find the greatest common divisor first. Step one, divide the smaller number into the larger number. Okay, so let's divide that. The remainder is not 0. So we're going to repeat the process. We're going to divide the remainder into the previous divisor. Okay, so that's going to be what? That's going to be 5. The remainder is still not 0. We need to do another step. Okay, so once the remainder is 0, we stop there. And the greatest common divisor is going to be the last divisor. Okay, so the greatest common divisor of 231 and 504 is 21. We're going to use the relationship between the numbers, the least common multiple, and the greatest common divisor to find the least common multiple. Okay, so the greatest common divisor of 231 and 504 multiplied by the least common multiple of 231 and 504 is the product of the numbers. Okay, so that's 21 times the least common multiple, which we haven't found, and the product of these two numbers is 116,424. And the least common divisor is 116,424 divided by 21. So conclusion, the least common multiple of 231 and 504 is 5,544. Okay, so I'm going to do, I will finish this section with a couple of applications. One application of the greatest common divisor and another application of the least common multiple. So this problem number 70 on page 248. Carla and Laverne are nurses who occasionally work in the emergency room. Carla works in the emergency room every 6 weeks, and Laverne works in the emergency room in the ER every 8 weeks. If they have just worked together in the ER, in how many weeks will they work in the ER together again? Okay, so we know that Carla if they just work together, Carla will come back in 6 weeks, then 12 weeks, then 18 weeks, 24, 30, and so on. And Laverne, she will return after 8 weeks, then after 16 weeks, next after 24, after 32, after 40, and so on. And you can see that after 24 weeks, they will work in the ER together again. Okay, so we need to find the least common multiple. Of 6 and 8. So these were smaller numbers. Fortunately, we can just find the least common multiple and greatest common divisor by listing the numbers one by one. And we can see that the least common multiple is 24. So the least common multiple of these two is 24. And they will work together again in the ER after 24 weeks. So that was an application of the least common multiple, and the last application is going to be an application of the greatest common divisor. I didn't write down the page number. That was, oh yes, I did. That's 248. So that's the same page. So in a medical supply room, there are 36 packages of type O positive blood and 30 packages of type AB negative blood. It is important not to confuse these two types of blood. If we want to stack piles of each type of blood on a shelf with only one type of blood in a pile, what is the largest number of packets of blood that we can have in each pile if each pile is of the same size? Okay, so we're going to divide them. Just from the context, you can determine whether it is the GCD or the LCM. In this case, they are going to divide the piles into piles of same size. So we're going to find the greatest common divisor of 30 and 36. So we're going to do that by using a prime factorization. So 30 is 5 times 6, and 6 is 2 times 3. And 36 is 6 times 6, where 6 is 2 times 3. So 30 is 2 times 3 times 5, and 36, it's 2 times 2 times 3 times 3. So the greatest common divisor of 30 and 36, they both are divided by 1, 2, and 1, 3, and that's it. So the greatest common divisor is 6. And at the end, they need to divide them into piles of 6. That is 5 piles of O positive and 6 piles of AB negative. Okay, so this is it. With this, I finished the first section on number theory and divisibility. And thank you for listening.